Hello, today we are going to solve the question number 15 from ISS 2019 paper 2. Here we are given two random variables x and y, and they are independent random variables following uniform 0, theta. Given a testing problem where the null hypothesis is theta equals to 1 against the alternative which is theta equals to 2, we need to find the type 1 error and the power of the test based on the critical region x plus y greater than 0.75. Now we are given four options and we need to find the correct one. So let's start. Let z equals to x plus y, where x is uniform 0, theta and y is uniform 0, theta also, and they both independent. They are mutually independent random variables. Now under h naught, theta is equals to 1. Therefore the type 1 error is equals to probability under h naught z greater than 0.75. Okay, now we need to find the sampling distribution of the random variable z. Okay, so this is the portion from which we need to find the sampling distribution of z. As both the random variables following uniform 0, theta and under h naught, they both follows uniform 0, 1, as the value of theta under h naught is 1. Therefore, the pictorial representation looks like this. So there are two possibilities, that z is 0 to 1 or z is 1 to 2. So first we draw the portion where z is 0 to 1. So this is the straight line which defines z is equals to x plus y. Now it is pretty much obvious that this portion is z. Okay, therefore the area under this portion is z square by 2, because this is a triangle with two sides z and one angle is 90°, or this is a right angle triangle. Therefore the area of this triangle is z square divided by 2. Okay, now the second portion is z is in between 1 to 2. So the pictorial representation looks like this. Okay, and our required area is the lined portion. Now first we have to find this coordinate. Here in this coordinate the x value must be 1 and the y value is z minus ax, where the value of x is 1. Therefore the y coordinate is z minus 1. Therefore this portion is equals to z minus 1 and this portion is equals to 2 minus z minus 1, 1 minus z minus 1, that is plus 1, that is 2 minus z. So this portion is also 2 minus z. Therefore, the area under the line will be 1 minus half of 2 minus z whole square. Okay, as the area of this triangle is half of 2 minus z whole square, therefore the area under this straight line y equals to x plus z, z equals to x plus y, is must be 1 minus half of 2 minus z whole square. Therefore, the CDF of z will be z square divided by 2 when z is in between 0 to 1, and when z is 1 to 2, the value of CDF is 1 minus half of 2 minus z whole square. Okay, now the type 1 error is probability under H naught z is greater than 0.75. So we can write 1 minus probability under H naught z is less than equals to 0.75. So the value of probability z is less than equals to 0.75 is nothing but z squared divided by 2, where the value of z must be 3/4 or 0.75. So we get 3 by 4 whole square divided by 2. This results in 9 by 16 uh, multiplied by 2, therefore 1 minus 9 by 32. Okay, so it is equals to 23 divided by 32, which nearly 0.72. So the type 1 error is 0.72. Now we need to find the value of power. Now we know that the power of test is equals to probability under each one z is greater than 0.75. Okay, now under h1 or under the alternative, the value of theta is 2. Therefore, the pictorial representation of z is equals to x plus y looks like this, where this point is 2 comma 2, it is 0 comma 0, it is 0 comma 1, and sorry, it is 1 comma 0, and it is 0 comma 1. Okay, so uh, as the first portion, there are also two possibilities of z, that is one is z is 0 to 2 and another one is 2 to 4. So first we consider the first case, which is z is 0 to 2. In this case, z is looks like this, and the area under this line will be this yellow portion. The value of this portion is z, it is also z. Therefore, the area under this line will be half of z square. Okay, and when z is between 2 to 4, the pictorial representation of this portion looks like this. This is 2 to 2, this is 0 to 0, this is 1 2 to 0, it must be 2 to 0, and this is 0 to 2. Okay, so our required area is this portion. Now we need to find this coordinate first. The x value of this coordinate must be 2. Now y is equals to z minus x, and the value of x is 2, therefore y coordinate is z minus 2. Therefore this portion is equals to z minus 2, and this portion must be 2 minus z plus 2, that is 4 minus z. So this portion will be 4 minus z also. So the area under the line is 4 minus half of 4 minus z whole square. As the area of this triangle is half of 4 minus z whole square, therefore the area under this line will be the total area minus the area of the triangle, and the total area is 4 as it is a square of side 2. Therefore the area under this line will be 4 minus half of 4 minus z whole square. Now we need to find the CDF of z. CDF of z will be z square divided by 2 whole divided by 4. As CDF is a measure of probability, therefore probability is nothing but, a geometrical probability is nothing but the required area divided by the total area. Okay, geometric probability is equals to the required area divided by the total area. Now the total area in this case is 4. In the above case the total area is 1, so the divisor is not required in that case, but in this case we need a divisor 4 when z is in between 0 to 2, and when z is between 2 to 4, the value of the CDF will be 4 minus half of 4 minus z whole square divided by 4. Okay, so the power of the test, the power will be probability under H1 z is greater than 0.75. We can write 1 minus probability under H1 z is less than equals to 0.75. Now z is less than equals to 0.75 under H1, which results in 1 minus 3 by 4 whole square divided by 2 whole divided by 4, which results in 9 by 16 multiplied by 2 multiplied by 4, that is 32, 128. Now 128 minus 9 divided by 128 is equals to 119 divided by 128, which results in 0.93 approximately. Therefore the power of the test is 0.93 and the type 1 error is 0.72. Therefore the option C is the correct answer. So we can write option C is correct. Okay, so that's all for today. Thank you very much.